Now we're going to discuss about exponential function, find the domain and range for this exponential function. So for domain, as I mentioned before, domain for exponential function is not a special case, so you can notice that its domain always negative infinity to infinity. Meanwhile, for range, so we can see this example, y is 0 to infinity. For range, this exponential is a special case. As range, we will refer to Castro. So E is for exponential. How are we going to see it? We will close this exponential. So you can notice that the coefficient here is positive. So that's why it having a positive infinity. The number outside here is 0. So it will be 0 up to infinity. But this 0 is not included because that 0 is an asymptote for the graph. So the graph will not going to touch the value 0. It will go near to the value 0 only. So for this graph, also having 0 to infinity. Why? Because when we close the exponential, you will notice that the coefficient here is positive. So we will positive infinity. The value outside will be its minimum value, which is 0, which is the location for asymptote. So domain always negative infinity, infinity, not special case, generally. Range, yes, so we have to find it. So about the graph. About the graph, exponential will having 4 types of the graph. You will have the asymptote, whether it shoot up to the right or it shoot up to the left. So make sure you must draw the properties of asymptote where our graph will go near to it and you can see it is parallel to our asymptote. Okay, so this is the type of shooting up to the right or to the left, or we were having the graph shooting down. So here will be our asymptote. So shooting down to the right. So we go shooting down to the left. So whether shoot up or shoot to the left, shoot to the right or shoot to the left, it will depends to our power. So if the power is in positive, it will be shooting to the right. So when your power having a negative x, so it will shooting to the left. And then whether it's going up or going down, it will depend to your range. So once you see your range 0 to infinity, so this is the graph shooting up. Positive power, so shoot up to right. Then negative power, shoot up to the left. So make sure you draw this asymptote. This is the place where the graph will go parallel and then you only shoot up. So for the graph, now let's say for this example, domain always negative infinity to infinity. Range, how we get this? When we close this exponential, you can get this is negative infinity. Value outside is 0. So same as here. When I close this exponential, you can see this is negative infinity. Value outside here is 0. When we read this range, alright, so exponential got 4 patterns, but the most probably you must know whether it's go up or go down first. Then look at out your power, whether shoot to the right, shoot to the left. So you can see when negative 0 to negative infinity to 0 means this graph is going to the go down, shoot down. So 0 to the negative part infinity. So you can go as downward as you can. So this is downward graph. So whether go downward for left hand side or right hand side, then it will be depending to your power. So you can see e to the power of x here is positive. So that's why you go parallel first, then it start to shoot down to the right hand side. And this one it go parallel first, then it start to shoot down to the left hand side because the power is in the coefficient of negative x. Now we're going to see our example here. we say state the domain and range for the following function, and then sketch the graph. So for question A, domain, not a special case, so always infinity to infinity. Meanwhile, for range, yes, exponential is a special case. So when we close this, we can see this is positive infinity. And then value outside here is 0. So this 0 is its asymptote. So it will not included. So that's why we have an open bracket. So what do it means here? Your exponential graph 0 to infinity means there will be the type of shooting up. Okay, asymptote and shooting up. Whether shooting up to the right or shooting up to the left, then depends on your power. Your power is power to positive, so it will shooting up to the right. So this is not the correct shape. After we identify the pattern, so we can start draw, set up our x-axis and y-axis. So now I can start drawing. Draw the asymptote first. So where's the asymptote? You can see the minimum value that you're having here for the range here, where your y is 0. So it means your asymptote is occur at y equals to 0. Label your asymptote. Then we start to draw our graph. Go parallel first, then start shooting up. So this is the characteristic that the graph having asymptote. So what's the y-intercept? So this one we need to calculate. Y-intercept will be calculating on x equals to 0. Substitute to our function 3 to the power of 0. So it is equals to 1. So after labeling our intersection and label our graph. So this is the complete graph that we need to show. Next, we go for question B, where our function here is gx equals to e negative x minus 2. Okay, domain for the function g, it will be not special case. So negative infinity to infinity. Meanwhile, the range for the function g here, then we will close. We will close the exponential. You can see the coefficient here is positive, so means it's up to positive infinity. What's your minimum? It will be negative 2, not included, because this negative 2 is for the value for your asymptote. So negative 2 up to infinity means that your graph is shooting up. So shooting up, whether to the right or to the left, then it depends on its power. So this power is having a negative coefficient, so it is shooting to the left. So after we identify this shape of the graph, we can start set up our x-axis and y-axis to draw out the graph, where we draw the asymptote first. So the asymptote we refer to the range here. The minimum value you can go is y equals to negative 2. So asymptote y equals to negative 2. Label your asymptote. Then we know that our graph, we're going to shoot up. We were going to intersect with y-axis. So we have to be careful here whether we intersect at positive or we intersect at 0, or we may intersect at negative. So I didn't draw first. I find out the y-intercept so that to avoid I overshoot or underestimate the intersection. So calculate y-intercept, where we're going to substitute x equals to 0 to our graph. E to the power of 0 minus 2. So it will be 1 minus 2. It will be negative 1. So don't overshoot the intersection here at negative 1. So we'll go parallel to the asymptote, and only start to shoot up here. Lastly, we label our gx e negative x minus 2. Then notice that our graph also intersect with x-axis. When we intersect at x-axis, we also need to label. So x-intersect, we're going to let this equation y to be 0. So e negative x minus 2 to be 0. So e negative x equals to 2. So log your e, so it will become ln 2. So x will be negative ln 2. So just label this is negative ln 2. Then we proceed for question C, where our function here is equals to e to the power of x plus 1. So state out our domain for this function. Exponential, not a special case, so infinity, negative infinity to infinity. Meanwhile, range, so range is a special case, we need to calculate, so we were going to close up, we were going to hide the exponential here. You can see up here is coefficient of positive, means that this graph will go for positive infinity. The value up here is 0, so 0 to positive infinity. So from this graph, we can notice that 0 to infinity means this graph is going up, going up. So asymptote at the bottom, you'll be going up to the right or going up to the left. So we are going to observe here where your x here, your power here, your x here is a positive coefficient. So you're going up to the right. Then we can start set up our x-axis and y-axis. We draw our asymptote. Asymptote is the value, minimum value here, which is 0. So label your asymptote, y is 0. Then we draw our graph, which is parallelly, then going to shoot up to the right. So exponential graph, label. At the same time, we notice that it having an intersection at y-axis. So we calculate y-intercept where x equals to 0. So there will be e to the power of 0 plus 1. So y will be e1. So e1 will be equals to 2.72. So lastly, kx will be equals to negative e2x plus 1. Domain of the function, as usual, negative infinity to infinity. Meanwhile, for the range, so we can read the range here. When we close the exponential here, when I close the exponential here, I can see I close the exponential here, so I can see outside the coefficient is negative. So means it will start from negative infinity up to maximum is 1. So 1 is not included. From here, we're going to identify whether your exponential shoot up or shoot down. So negative infinity means this is downward. So your exponential here, you're going downward. Whether to the left or to the right, then depends on our power here. Notice that our power here having a positive coefficient means it will going to the right. So now we can set up our axis. X-axis, Y-axis. Draw our asymptote first. Where's our asymptote? Then you can see the maximum you can go is 1. Means your asymptote is located at y equals to 1. And then your graph will going parallelly, then go down to the right hand side. So when we go down to the right hand side, so we have to be careful here whether it is intercept at positive or 0 or negative. So before we draw it, we identify it by calculation. We find out what is your y intercept. When x equals to 0, so substitute into our function e to the power of 0 plus 1. So substitute here. E to the power of 0 it is negative. It is 1. So negative 1 plus 1 is 0. So it will be automatic intercept at origin. So now we can proceed our graph. Parallelly, then start. Go down to the right hand side. Intersecting at 0. Then after that, we label our function. This kx is equals to negative e to x plus 1.